So, sometime in mid 2026, while you were just going about your normal life, maybe pouring a cup of coffee or sitting in traffic or just scrolling on your phone, you quietly became a minority on the internet.
Yeah, and no one sent you an alert about it either.
Right, there was no pop-up notification.
Yeah.
But the very fabric of the digital world completely flipped underneath you.
It is a profound, almost eerie milestone when you think about it. I
Huh?
mean, we've spent decades designing and building the internet around one core assumption.
Which is that there's a human being on the other end.
Exactly. The assumption that the entity clicking a link or reading an article or buying shoes is a human with a heartbeat. Like the whole architecture was built for human reaction times, human reading speeds, and human attention spans.
And that assumption is now officially obsolete.
It's totally gone.
Let's get right into the data that proves this, because this genuinely made me do a double take. According to Cloudflare, automated requests now account for 57% of global HTML web traffic.
57%.
Yeah, 57%. That leaves human visitors, you, me, everyone listening to this at just 43%. We are the minority now. We are officially living in a machine's world.
And, to be totally clear, we are talking about HTML traffic here,
Hmm.
not just the back-end API calls that apps use to talk to each other.
Right, because that's always been high, right?
We expect machines to talk to machines via APIs. That's just how your weather app gets its data from some meteorological server. But HTML, well, that's the presentation layer.
It's the visual code.
Exactly. It dictates how a website looks to a human eye. The fonts, the layout, the images. So when 57% of the requests asking a server to render a visual web page are coming from machines, it indicates a structural mutation.
Because the bots aren't just passing data in the background anymore.
Right. They are literally reading the web the way we do.
And that right there is the mission of our deep dive today. We're not just going to talk about cybersecurity or, bore you with server specs.
Please no.
Yeah, we are diving into something much bigger, something foundational to your daily life. We're talking about media economics. We have a huge stack of sources detailing how this massive shift from human to machine traffic is just absolutely breaking the traditional business model of the internet.
It's shattering it, really. And we're going to look at how a completely new system, what experts are calling the agentic economy, is rising from the ashes to replace it.
Right, because if the economics of the internet change, the internet itself changes.
Fundamentally, we're going to explore how websites are fighting back, how they're actively preparing to sell your favorite digital content directly to autonomous robots, and what that actually means for the web services you use every single day.
So, to understand why the economics are breaking down, I think we first need to understand how the traffic itself has fundamentally mutated. Because when we say automated traffic or bots, I feel like a lot of people picture the old internet.
Oh, for sure. They picture traditional search engine crawlers, like the Google bot from, say, the 2010s.
Right. The mental model is basically a digital census taker. It just quietly roamed around, downloaded the static text of a web page, filed it away in an index, and moved on.
Yeah, it was very passive. And that passive model worked because it was incredibly lightweight.
Meaning it didn't use a lot of computing power.
Exactly. A traditional crawler would just ask the server for the raw HTML file, parse the text, look at the links, and leave. I mean, it didn't try to execute the JavaScript or load the interactive elements. It was just mapping the territory.
But the new reality is completely different.
It's structurally different. We're dealing with autonomous AI agents now. These are sophisticated systems that actively browse the web on behalf of users.
So they aren't just mapping.
No, they are doing tasks. They are comparing products across dozens of retail sites, verifying facts, filling out forms, parsing thousands of customer reviews. They are active, stateful participants in the web ecosystem.
I have to push back a little on the severity of this, though, because, we've had scraper bots forever, right? Price comparison sites have been scraping Amazon and airlines for 20 years.
Yeah.
So what is genuinely structurally different about an AI agent that makes it this existential crisis for the web's infrastructure? Isn't it just doing the same thing, maybe just a bit faster?
Well, the difference lies in the computational weight of the interaction. And crucially, the multiplier effect.
Okay, unpack that.
When a modern AI agent visits a website, it doesn't just download a static text file like those old crawlers did. Modern websites are essentially complex software applications running in your browser. So to understand what's actually on a modern page, The AI agent has to spin up what's called a headless browser.
Headless browser. Let's
Mm.
define that because that sounds like something out of a sci-fi horror movie.
It does sound creepy.
What is a headless browser?
So a headless browser is a full web browser, like Chrome or Firefox, running in the background on a server, but without the graphical user interface.
So it doesn't have a screen or a window you can actually see.
Right, but it has all the processing power. It executes the JavaScript, it renders the CSS, it waits for animations to finish, it triggers pop-ups. It does this because it needs to see the fully rendered page exactly as a human would, just so it can extract the right information or click the right buttons.
So it's simulating the entire human visual and interactive experience, just virtually.
Yes. And rendering a complex, JavaScript-heavy website requires massive amounts of CPU and memory, not just on the bot's end, but on the host server's end too.
Right, because the host server has to actually send all that stuff.
Exactly. The server has to keep the connection open, send all the heavy script files, and respond to all the asynchronous requests the headless browser is making as it navigates the page. It's incredibly heavy. And now you have to combine that heavy computational load with the multiplier effect of AI prompting.
Oh, right. Think about how you use an AI assistant today. Like you type in a prompt. Plan a weekend itinerary for Chicago, find the best-rated Italian restaurants with availability this Saturday, and check the weather.
Right.
You hit enter, and you wait maybe 3 seconds. To you, that's one action.
But behind the scenes, that single prompt spawns dozens, sometimes hundreds, of background web requests simultaneously.
Just instantly swarming the web.
Yeah. The AI agent spins up multiple instances of those resource-heavy headless browsers. It hits 5 different weather APIs, scrapes 20 different restaurant reservation platforms, reads through 50 travel blogs to cross-reference recommendations, and executes all the JavaScript on all those sites just to make sure it's getting real-time availability.
So your one human action instantly generated a massive swarm of heavy machine activity.
Exactly.
I like to think of the old internet as a public library. You know, people walked in, they browsed the shelves, maybe they pulled a book out, read it, put it back. It was paced by human speed and human physical limitations.
That's a great analogy.
But the new agentic internet is like an algorithmic stock exchange. It's this high-frequency environment where machines are aggressively trading information at light speed on our behalf in massive volumes.
And as millions of people adopt these AI assistants into their daily workflows, that multiplier effect scales exponentially. Websites are no longer just serving human readers who scroll at human speeds. They are serving autonomous software acting as intermediaries, pulling massive amounts of compute power.
So put yourself in the shoes of someone running a business online today. A publisher, a local news site, an e-commerce store. They're used to human traffic humans who look at ads, who might buy a subscription, who click affiliate links. What does this explosion of agent traffic actually look like on their end? Am I just seeing my server bills skyrocket for no reason?
Yes, that is exactly what you're seeing. They are experiencing dramatic, often completely unexplained traffic surges that correlate with zero economic return. From an infrastructure perspective, every time one of those headless browsers visits the site to scrape a menu or summarize a blog post, the server has to do the work. It pulls data from the database, renders the HTML, serves the images, keeps the connection alive. That consumes bandwidth and memory, which costs real money.
Because cloud hosting bills scale based on usage.
Right, so the server costs are skyrocketing.
Mm.
But the agents aren't looking at the display ads. They don't trigger the viewability metrics that advertisers pay for. And they definitely don't impulse buy anything.
So the website owner gets a massive increase in automated requests that generate absolutely zero economic value, while their overhead goes through the roof. It's just a pure economic bleed.
And it corrupts their business intelligence too.
Oh, how so?
Well, imagine you run a marketing campaign and you get 100,000 new visitors. But 57,000 of them are bots executing JavaScript and then leaving without buying anything.
Mm.
Your conversion analytics look terrible. You might actually fire your marketing agency, when in reality the campaign worked fine, but the web's baseline traffic has just fundamentally shifted.
That is just wild. And that is the economic strain of just the legitimate AI agents doing their jobs, the helpful assistants booking our tables and summarizing our news. But this explosion of agent activity isn't just expensive, it's providing perfect camouflage for malicious actors to hide in plain sight.
Yes.
Which brings us to a massive shift in cybersecurity, the new era of bot bombings.
To understand this, we have to look at the evolution of the DDoS attack, the distributed denial of service. Historically, a DDoS attack was just a brute force bandwidth flood.
Like trying to shove too much water through a pipe.
Exactly. Attackers would compromise thousands of computers and direct them all to send a massive fire hose of garbage data at a website's IP address. The goal was to completely clog the network pipes. Legitimate traffic couldn't get through because the sheer volume of data exceeded the physical capacity of the victim's internet connection.
Right, these were the old layer 3 and layer 4 attacks operating at the network and transport layers. Just pure dumb volume. It was noisy, and frankly, we got pretty good at mitigating it. Like Cloudflare and AWS would just absorb the garbage data at the edge of the network and filter it out before it ever hit the main server.
Yeah, they acted like a massive sponge.
But we are seeing a massive shift to modern layer 7 attacks, and layer 7 is the application layer. What does that actually mean in practice?
Well, if the old attacks were trying to clog the pipes, Layer 7 attacks are trying to exhaust the brain of the server. Yeah. Instead of sending a fire hose of garbage data, the attackers send a trickle of highly complex, perfectly formatted requests. They target the application logic. They basically want to force the server's CPU and database to work as hard as physically possible.
Give me a concrete example of that. How do you exhaust the brain of a server without sending a lot of data?
Take a complex search function on an e-commerce site, or a dynamic filtering system. An attacker programs a bot to constantly search for highly specific, convoluted combinations of items.
Like what?
They might filter a massive database by price, color, size, availability across multiple zip codes, and ask the server to sort the results by some complex metric. Or they exploit GraphQL APIs.
Let's pause there. What's a GraphQL API in this context?
It's basically a way for a website front end to ask the back-end database for exactly the data it needs. But if it's poorly configured, an attacker can send what's called a deeply nested query.
Nested query.
Right. They ask the database to fetch a user, then fetch that user's friends, then the friend's recent purchases, then the reviews of those purchases, looping deeper and deeper in a single request.
Okay, so to the network pipe, it just looks like a tiny normal text request. It takes up almost zero bandwidth.
Exactly. But when that tiny text request hits the back-end database, it triggers a cascading nightmare of computational work. The database has to join multiple massive tables, sort millions of rows, and hold all that intermediate data in its active memory.
And the server just crashes.
The memory heap maxes out, the processor threads get entirely starved. A relatively small number of bots, maybe just a few hundred asking these complex questions, can completely bring a massive enterprise server to its knees.
It's like trying to sabotage a restaurant, not by blocking the front door with a mob of people, but by sending in just 3 people who sit down, look like regular customers, and order the most complicated, time-consuming, multi-course off-menu item imaginable.
Yes.
The kitchen completely freezes up trying to cook it, all while the front door looks totally normal.
The kitchen is overwhelmed, and no other tickets can get processed. And the truly terrifying part of this is the camouflage.
Because of the AI agents.
Right. In the past, if a server suddenly saw a burst of highly complex database queries, security tools would flag it as anomalous behavior and block the IP. But in the agentic era, we just established that millions of legitimate AI assistants are constantly spinning up headless browsers and executing highly complex queries on behalf of real users.
So the malicious bots blend in perfectly. They look exactly like a helpful AI agent trying to find you a hotel room or scrape a data set for a research paper.
The baseline of normal internet traffic has become so complex and computationally heavy that malicious application layer attacks can hide seamlessly within the noise.
And the development side of the tech industry is actually making this vulnerability worse right now, ironically because of AI. We are in the middle of a massive boom in AI-assisted coding. Developers are using AI to write applications faster than ever before.
AI coding assistants are incredible for development speed, but they introduce systemic risks. They are trained on vast repositories of open source code, and a lot of that contains outdated or insecure patterns.
Right.
But more importantly, AI tools optimize for functionality. They write code that successfully delivers the user experience, but they often fail to implement defensive guardrails.
Because implementing security is tedious, and it doesn't look like a feature to the end user.
That's exactly the problem. We are seeing a rush of applications pushed to production with insecure API configurations, missing rate limits, and unvalidated input fields. The code works, but it hasn't been hardened against abuse.
So attackers are actively scanning for these newly deployed AI-generated APIs.
Yeah, and exploiting them for credential stuffing, where they test millions of stolen passwords against login endpoints, or they use them as entry points for the Layer 7 database exhaustion attacks we just discussed.
Okay, I can definitely hear a listener thinking right now, wait, what about the defenses we've relied on for years? What about the I am not a robot checkboxes?
Yeah, the classic CAPTCHA.
Right, the CAPTCHs where you have to click all the traffic lights or the crosswalks. If bots are taking over, why aren't those stopping them? I mean, I have to do them all the time.
Well, traditional challenge-based defenses have completely collapsed. They are obsolete. CAPTCHs were designed for an era where bots were relatively simple procedural scripts. But today, the robots are literally better at solving visual puzzles than human beings are.
I feel like we really need to unpack the mechanics of that because it sounds like a joke, but it's a massive infrastructural failure. How does a bot beat a visual puzzle meant for a human brain?
There are two main vectors here. First, there are cheap commercial CAPTCHA solving services. An attacker pays a fraction of a cent per puzzle, and the service uses an API to route the image to a human click farm halfway across the world. A worker there solves it and sends the token back in seconds.
Wow. So they are weaponizing cheap human labor to bypass the human check.
Yes. But the second vector is purely technological, and it's taking over completely. Attackers are deploying AI-driven browser agents equipped with advanced computer vision pipelines.
Like AI looking at the puzzle.
Exactly. When the CAPTCHA presents a grid of images and asks you to select the crosswalks, the AI takes a screenshot of the grid. It passes that image through a lightweight neural network trained specifically on object detection, similar to the models used in self-driving cars.
And a model trained on autonomous driving data is obviously going to be incredibly good at identifying crosswalks and traffic lights.
It identifies them faster and more accurately than the human optical nerve. But the security companies knew this was coming, so they updated CAPTCHs to not just look at the final click, but to analyze the mouse movement.
To see if you move like a human.
Right. They wanted to see the messy, imperfect trajectory of a human hand moving a mouse.
Right.
Because a simple bot would just teleport the cursor instantly to the checkbox.
So what did the attackers do?
They integrated Bezier curve algorithms into their bots.
Bezier curves.
Yeah, mathematical curves. The bot mathematically generates a curved, slightly randomized, imperfect mouse trajectory. It simulates the biomechanics of a human wrist, complete with micro-hesitations and slight overshoots, before clicking the box. It outwits the behavioral safeguards perfectly.
That is insane. So it basically pretends to have a wrist. And what about just blocking their IP addresses? If someone tries to log in thousands of times from the same place, can't we just ban their IP?
No, IP-based rate limiting is dead. Modern bots operate on massive, globally distributed residential proxy networks. Instead of launching an attack from a single data center in one country, the attacker routes their traffic through millions of compromised devices.
Like what kind of devices?
Smart TVs, internet-connected cameras, home routers, and legitimate mobile phones that have been infected with malware.
So the attack is coming from inside the house, literally. It looks like it's coming from a residential neighborhood in Ohio or a coffee shop in London.
Exactly. If a security system blocks an IP address, the botnet simply rotates to a new, clean residential IP for the very next request a second later. You cannot block them based on origin because the origin is constantly shifting and looks perfectly legitimate.
Okay, if the old gates are broken, if the bots can solve the CAPTCHAs, if they can simulate human wrists, and if they can hide behind fake residential IPs, how is the internet not just crashing constantly? How are cybersecurity vendors actually keeping the infrastructure alive right now?
We are seeing a complete paradigm shift in defense. The industry is moving away from isolated security challenges, like making you solve a puzzle at the door, and moving towards zero trust, continuous, invisible evaluation.
Invisible evaluation. So they aren't looking for one big proof of humanity.
No, they are aggregating hundreds of microsignals in the background to calculate a continuous risk score while you browse.
What kind of microsignals?
Advanced browser fingerprinting is a massive part of this. When you load a web page, the server asks your browser to render a hidden, complex graphical element using your device's specific graphics card and graphics drivers.
Okay, why would it do that?
Because every hardware configuration is slightly different at the microscopic level. The way the graphic is rendered creates a unique mathematical hash. It's essentially a fingerprint of your specific hardware.
Oh, wow. So even if the bot is routing its IP through a smart fridge in Ohio, the server knows the hardware rendering the page is actually a massive Linux server in a data center somewhere else.
Exactly. Defenders also analyze the subtle discrepancies in the TCP/IP network packets, the fonts installed on the operating system, the battery level status APIs, and the exact order in which JavaScript is executed.
They're looking for the imperfections.
Yes, the minute imperfections and hardware constraints that prove you are a flesh-and-blood human using a consumer device. Furthermore, we are seeing a massive push toward cryptographic device IDs.
How does that work?
It leverages the physical security chips inside modern devices like the TPM, or Trusted Platform Module, in Windows machines, or the Secure Enclave in Apple devices. Websites use protocols like WebAuthn to ask your device's hardware chip to cryptographically sign a challenge.
Basically vouching for itself.
Right. The hardware attests, yes, I am a legitimate, unmodified consumer device. A bot running in a virtual machine on a cloud server cannot fake that cryptographic signature because it lacks the physical hardware chip.
So it's a silent cryptographic war being waged on your browser every single time you load a page. The server is interrogating your hardware, analyzing the mathematical imperfections of your graphics card, and scoring your behavior all in milliseconds just to decide if you are allowed to read a recipe.
Yes. And since we can no longer easily tell humans from bots just by looking at the front door, security researchers have to analyze the macro behavior of the botnets over time to figure out who is pulling the strings and what their ultimate strategic goals are.
Yep. Which brings us to a fascinating analysis of the geopolitics of scraping versus sabotage. When researchers zoom out and look at the petabytes of data flowing through these global proxy networks, they see distinct operational patterns. And these patterns point to fundamentally different strategic goals depending on the region.
We do need to approach this with analytical rigor, though, relying strictly on the technical telemetry provided in public cybersecurity reporting.
Right. Impartially looking at the data, what does the data say about, say, China-linked infrastructure?
When analysts monitor infrastructure linked to the Chinese technology ecosystem, for instance, they observe a heavy, sustained focus on large-scale AI web crawling.
The vacuum cleaners, the massive data extraction operations.
Exactly. The goal here is commercial and strategic data harvesting. It is massive content scraping. The objective is not to break the website or deploy ransomware or disrupt services. The objective is acquisition at a staggering scale.
Just sucking up everything they can find.
They are vacuuming up the public internet academic papers, news archives, public forums, code repositories, social media sentiment to train massive language models and build sovereign AI ecosystems.
Because data is the new oil, and they are building the biggest pipelines. I mean, if you have the most data, you build the most capable AI models. It's an extraction operation to build a strategic moat. Contrast that with the operational patterns researchers see originating from infrastructure linked to Russia or various Eastern European cybercriminal syndicates. What does the telemetry show there?
That behavior profile is fundamentally different. It is highly aggressive and targeted. The telemetry associates these operational groups with targeted intrusion campaigns, mass credential theft, ransomware deployment, and the sophisticated Layer 7 application exhaustion attacks we broke down earlier.
So they aren't interested in vacuuming up a million recipes to train an AI. They are looking for the one database that holds the credit card numbers, or they want to take down a power grid's payment portal.
Right. Their focus is disruption, extortion, and targeted theft directed at governments, critical infrastructure, and commercial enterprises. So if one strategic paradigm uses bots as giant vacuum cleaners to hoard global knowledge, the other paradigm uses bots as lockpicks and battering rams.
I need to interject with a massive asterisk right here, though. As a casual observer, if a news headline says a cyber attack originated from an IP address in Beijing or Moscow, the immediate assumption is that the government of that country launched the attack. But the architectural reality of the internet makes that assumption incredibly dangerous, right?
It is a crucial analytical caveat. The security professionals monitoring this traffic explicitly caution that IP geolocation alone is inherently flawed evidence for attribution. You cannot simply look at a map of where the network traffic is physically originating and declare culpability.
Because of the massive residential proxy networks we talked about earlier, the hijacked smart TVs and routers.
Exactly. An advanced persistent threat actor sitting in one country will purposefully construct an operational infrastructure that routes their traffic through compromised devices located in dozens of adversarial countries. They deliberately obscure their true origin.
So it's smoke and mirrors.
A sophisticated Layer 7 attack targeting a financial institution in New York might appear, on paper, to be originating from thousands of home routers located in London, Tokyo, and Sydney. But the actual command and control server orchestrating the attack could be sitting in a basement in St. Petersburg, or frankly, a basement in New Jersey. Attribution in the digital age requires deep behavioral analysis, reverse engineering malware, and tracking financial flows. IP addresses are just masks.
And while the disruptive attacks the ransomware, the massive DDoS events that take down banking portals make the front pages because they cause immediate panic. If we tie this back to our core focus of media economics, it's actually the quiet, massive scraping operations that are forcing a crisis. The battering rams cause headlines, but the vacuum cleaners are causing bankruptcies.
The scraping operations are an existential threat to publishers because they are extracting the core product, the intellectual property, the investigative journalism, the creative writing, without engaging in the economic exchange that keeps a publisher financially viable.
So to truly grasp the magnitude of this crisis, we have to look at the economic model that is currently buckling under this pressure. We have to look at what publishers and creators were doing right before the bots took over the creator economy.
Right.
There is a striking visual metaphor provided in our sources that illustrates this perfectly. It's a satirical cartoon titled The WB, House of Endless Escape. I'll describe the imagery for everyone listening. The internet is depicted as this dense, overwhelming neon-lit entertainment complex, part seedy casino, part 247 carnival. The imagery is claustrophobic. It shows people completely engrossed in screens, ignoring a literal arrow pointing to real life.
And there are signs everywhere advertising things like top-shelf social media and infinite content.
Yeah. But the most important detail in the cartoon is the cost of entry. The sign at the front of this carnival doesn't ask for a credit card. It lists the admissions price as attention, time, energy, soul.
Oh, it's heavy.
It's a vivid illustration provided in the source material representing the peak and perhaps the toxic exhaustion of our current digital ecosystem. That isn't just a dramatic artistic statement, that is the literal macroeconomic thesis of the last 10 years of the internet.
The image perfectly encapsulates the cold, hard reality of what we call the creator economy. For the last decade, the primary economic engine of the web hasn't been direct monetary exchange. It has been the monetization of human attention and dopamine.
It's an extraction industry.
Yes. And the natural resource being mined, refined, and sold to advertisers is human time.
The business model relies on keeping a human being looking at a screen for as many seconds as possible so you can serve them as many ads as possible. But as a macroeconomic model, it has hit a biological wall.
That is the exact bottleneck the image is illustrating. In any market, you have supply and demand. Thanks to the rise of self-publishing platforms, smartphone cameras, and now generative AI, we've created an unprecedented, near-infinite supply of content. Millions of hours of video are uploaded every day, trillions of words of text. The supply side of the market is completely unconstrained.
But the demand side, the human audience, is strictly constrained by biology.
Precisely. A human being only has 24 hours in a day. They need to sleep, work, and eat. They have a limited cognitive capacity to process information and a limited biological capacity to experience dopamine spikes before exhaustion sets in. Human attention is a biologically capped resource.
And we've maxed it out.
The creator economy has maximized the extraction of that resource to an unhealthy degree. The customer acquisition cost, the amount of money and effort it takes to get a human to simply look at a new piece of content, has skyrocketed because the market is totally saturated.
The humans are tapped out. The attention economy is running on fumes. And right at this exact moment of peak human exhaustion, when publishers are fighting tooth and nail for every single human eyeball just to pay their hosting bills, generative AI steps in and completely breaks the foundational financial agreement of the open web.
This is where the shift from human to machine traffic crosses from a technical headache into a terminal economic crisis.
So let's unpack the mechanics of how that old deal worked for 20 years. The historical deal between search engines and publishers.
It was a mutually beneficial symbiotic relationship based on a clear exchange of value. A search engine company like Google would send its automated crawler to a publisher's website. Let's use a tech blog reviewing a new smartphone as an example.
Okay.
The crawler ingests the text of the review. The publisher allows this scraping to happen for free. They pay the server costs to host the bot, and they don't charge the search engine for the intellectual property.
Why would they give it away for free? What was the trade?
Because the search engine promised to act as a directory. In return for taking in the data, the search engine indexed it. When a human user searched for reviews of the new smartphone, the search engine provided a list of hyperlinks, directing that human user away from the search engine and back to the publisher's website.
So the search engine provided distribution. And once the human is physically on the tech blog's website, the publisher controls the monetization. They can show the human an ad, they can try to sell them a premium subscription, they can track their cookies for retargeting, or they can get them to click an affiliate link to buy the phone. The human traffic was the currency that paid for the journalism.
But that entire equation relies on the link. Generative AI destroys the link. The architecture of modern AI search, often called RAG, or Retrieval Augmented Generation, fundamentally alters the data flow.
Break down how RAG works mechanically and why it kills the publisher's business model.
When a user asks an AI assistant about the new smartphone, the AI system still goes out and fetches the information from the tech blog, but it does not provide a directory of hyperlinks for the user to click.
It just reads it itself.
Yes, the AI ingests the raw information, synthesizes it, formulates a conversational summary, and serves the answer directly to the user within his own chat interface.
It's like someone coming into your restaurant, eating all the food, learning your secret recipes, and then opening a free buffet next door using your name while leaving you the bill for the ingredients.
That is exactly what is happening, and the asymmetry of the compute costs makes it even worse.
How so?
The publisher pays the massive server costs to render the complex HTML and JavaScript for the AI's headless browser to scrape the site. But because the human user gets their answer directly in the AI's chat window, the human never visits the publisher's site.
So the publisher gets zero human traffic, zero ad impressions, zero affiliate clicks. They bear 100% of the infrastructure costs of hosting the data and 0% of the economic benefit. It is a one-way extraction that leads directly to ruin.
And the Cloudflare data confirms this architectural shift is already dominant. Traditional search indexing bots, the ones that promise to send you human traffic, are shrinking as a proportion of total automated requests. Meanwhile, AI training crawlers and autonomous agents doing R-rate synthesis now make up the vast majority of crawler activity.
The bots are no longer building a map to send people to your house. They are building a replacement brain using your knowledge and keeping the users for themselves.
Yes.
So if you are a publisher right now, you used to only have two blunt options. Option one, you allow all the bots for free, preserve your place in the AI's training data, and slowly go bankrupt paying Amazon Web Services for the bandwidth. Option two, you update your firewall to block all bots entirely.
But if you block the bots, you drop off the map. You become invisible to the AI systems that the entire global population is now using as their primary interface for information. If the AI doesn't know you exist, you effectively cease to exist in the modern digital economy. It was a catastrophic lose-lose scenario for the open web.
Which brings us to the revolution, because a third option is finally emerging from the infrastructure layer. If the human attention economy is exhausted and the robots are the ones consuming the content, you have to figure out how to sell directly to the robots. Welcome to the agentic economy.
This is a fundamental macroeconomic paradigm shift.
Right.
We are moving from monetizing human attention to monetizing machine access.
Monetizing the machine.
Yes. Instead of treating bots solely as a cybersecurity threat to be blocked or a parasitic resource drain to be tolerated, infrastructure providers are architecting a system where legitimate, verified AI agents are treated as a brand new category of paying customer.
Cloudflare and other major network infrastructure companies are rolling out entirely new commercial frameworks to make this B2B, or really business-to-bot commerce, possible. Let's break down the mechanics of these frameworks. The first tier mentioned in the sources is called pay-per-crawl. How does that actually work at the server level?
Pay-per-crawl is the foundational tier. It allows publishers to establish a cryptographic toll booth at the edge of their network. Let's say a major AI lab is training their next-generation foundational model, and they want to scrape a decade's worth of archives from a major newspaper.
Under the old model, they just took it.
Right. But under pay-per-crawl, the publisher sets a wholesale price for raw data ingestion. Every single time the AI lab's authenticated crawler hits the server to download an article, an automated microtransaction is triggered. The AI lab pays a fee, maybe a fraction of a cent, just to access the raw text.
It's a licensing model for raw materials. You want the data, you pay for the bandwidth and the intellectual property up front, but that's just for the big training runs. The materials outline something much more complex and dynamic for the day-to-day operation of the web, called pay-per-use. What is the architectural difference here?
Pay-per-use is a dynamic attribution-based model designed specifically for the retrieval augmented generation era. In this model, the publisher isn't just paid a flat fee when the data is scraped. They are paid dynamically based on the utility of their content in real time.
Utility meaning how useful the data actually was to the end user.
Exactly. If a human user asks an AI assistant a complex question about a recent court ruling, the AI fetches data from a dozen different legal blogs, but it might rely heavily on one specific highly detailed analysis from a niche legal publisher to actually formulate its final answer.
So how does the publisher get paid for that?
The pay-per-use infrastructure tracks that attribution mathematically. When the AI generates the answer for the user, a smart contract protocol executes, and the niche legal publisher gets a dynamic cut of the revenue based on how heavily their specific data weighted the AI's final output. It links compensation directly to actual value generated.
I have to challenge the reality of this because it sounds great in a white paper, but how on earth do you price that in reality? I mean, a blog post about a chocolate chip cookie recipe is functionally a commodity. There are millions of them. But a breaking investigative report on financial fraud is highly unique. How does a publisher manually set prices for millions of URLs when the value of the information changes by the minute?
Well, they don't do it manually. This relies on automated dynamic pricing algorithms. The materials reference a landmark 2026 deployment study called the LM-Tree Agent Study. This was an experimental framework testing how dynamic pricing could work for AI crawlers in real time.
Dive into the mechanics of that study. How does an algorithm figure out the exact clearing price for a piece of content in milliseconds?
The LM-Tree study proved that rigid, flat-fee economics fail in the machine era. If you charge a flat 10 cents for every article, the AI simply won't buy the commodity cookie recipe, and you heavily underprice the highly valuable investigative report.
Right.
So the study deployed adaptive pricing algorithms, often utilizing what's called a multi-armed bandit model.
Explain the multi-armed bandit model.
Imagine you are at a casino, facing a row of slot machines, the multi-armed bandits. You want to find out which machine pays out the most, but the only way to find out is to spend money pulling the levers. You have to balance exploring, trying different machines, with exploiting, pulling the lever on the machine you currently think is best.
Okay, so how does that translate to web pricing?
In dynamic pricing, the publisher server is the casino, and the AI agent is the player. The server constantly adjusts the price of a specific web page based on real-time demand signals. If multiple different AI agents are suddenly aggressively trying to fetch a specific breaking news article, the server's algorithm recognizes the spike in demand and automatically increases the price of access for that specific URL. It explores higher price points.
And if the AI agents stop buying because the price is too high?
The algorithm lowers it until it finds the perfect clearing price.
It's algorithmic price discovery, happening in milliseconds without any human intervention.
Yes, and the economic results in the study were staggering. By implementing this dynamic, demand-responsive pricing, publishers increase their overall revenue by up to 65% compared to flat licensing fees.
65%.
Yes, 65% is a paradigm shift. It is the difference between mass media extinction and a highly profitable new digital economy.
If we zoom out and look at the grand economic evolution outlined here, it charts a very clear historical progression of how technology changes the way we value labor and output. The materials lay this out so cleanly. The evolution from the gig economy to the creator economy to the agentic economy. Let's trace that arc.
It's a progression of abstraction, really.
Yeah.
In the 2010s, we built the gig economy. Uber, TaskRabbit, DoorDash. The digital platform was just a routing mechanism to monetize human physical labor in the real world. The output was a physical ride or a delivered meal.
Then we abstracted further. We moved into the creator economy.
Here, independent creators weren't selling physical labor. They were selling digital intellectual property, YouTube videos, Substack newsletters, Twitch streams. The platform monetized human attention. The currency was the human capacity to watch an advertisement or pay a subscription.
But the human attention span reached its biological limit. The market saturated.
Which forces the third evolution, the agentic economy. In this era, the creator is still producing digital intellectual property, but the primary consumer, the entity they're negotiating with and monetizing, is a machine. It monetizes machine consumption and machine compute power.
And if you think about it from a content creator's perspective, this might actually be a relief. I mean, instead of fighting for the fractured attention of exhausted humans in a toxic, dopamine-fueled cage match, their new loyal audience is an army of verified, well-funded AI agents that can consume data 24/7.
Exactly. Machines don't get tired. They have an infinite capacity to consume, filter, and process information. It solves the primary bottleneck of the previous era. The unprecedented oversupply of generative content is suddenly met by an entity with an infinite programmatic capacity to consume it. The market balances out, but the participants are no longer entirely human.
But logically, building a store for robots requires entirely new digital infrastructure. We are talking about millions of microtransactions happening in milliseconds. How does a publisher even negotiate with a bot? Are robots swiping credit cards? We obviously can't use standard credit card processing for a transaction that costs a hundredth of a cent.
No, the latency and fees would destroy the whole system. This is where the architecture of the web is being rewritten. First, the concept of bot management is moving out of the IT basement and into the C-suite. It's no longer just a firewall blocking malicious IPs. Modern analytics platforms act as B2B gateways.
So they segment the traffic?
Right. A publisher's dashboard segments automated traffic using those cryptographic device IDs and behavioral scores we discussed earlier, so the publisher can decide who to block and who to charge.
And to execute the commerce without latency, we're seeing the evolution of entirely new machine-readable metadata standards. Think about how we navigate the web as humans. We use hashtags to categorize topics. We use hyperlinks to navigate. That is metadata designed for human eyes.
But the agentic internet requires signage for machines. Web pages are now being embedded with invisible, machine-readable licensing and commerce tags. They operate at the HTTP header level or within hidden JSON LD scripts in the HTML.
So what does a tag actually say?
A tag essentially broadcasts, I am an original investigative report. My license allows summary but prohibits full-text reproduction. The cost for API ingestion is 0.05 cents.
And how is the payment settled in real time?
It utilizes low-latency payment channels. When the AI agent requests the page, the server responds with an HTTP 402 payment required status code.
Which was a protocol built into the internet decades ago, but rarely used until now.
Exactly. The AI agent instantly reads the machine tag, checks its allocated microtransaction budget, uses its pre-established payment channel to send cryptographic proof of payment, and the server unlocks the payload containing the article. This entire negotiation, payment, and delivery happens in a few dozen milliseconds. No human intervention.
It is an entirely invisible, high-frequency digital economy operating underneath the surface of the websites we browse every day. But this raises the ultimate question, the one that impacts every single person listening to this right now. Building a store for robots requires entirely new digital infrastructure, and ultimately someone has to foot the bill. If these massive AI companies are suddenly losing money paying billions of dollars in microtransactions to publishers to access the data they use to scrape for free, who ultimately pays for that?
This is where macroeconomic theory hits consumer reality. The materials frame this perfectly. Welcome to the age of money for everything and yet everything for free.
Unpack that contradiction for me. If money is changing hands behind the scenes, how is it free for me? The consumer impact section literally warns, bites, beware.
At the surface level, consumer web services search engines, basic AI chat assistants will likely remain free to access. The tech giants know that charging a hard subscription fee for basic access destroys user adoption.
Right.
But these AI firms are already operating on incredibly thin margins. If their operational costs suddenly skyrocket because they have to pay publishers via pay-per-crawl and pay-per-use microtransactions, they have to recover those costs. They will pass them on to the consumer, just not in the form of a monthly invoice.
So if I'm not paying with my credit card, how am I feeling the cost of this new economy?
You will pay through manufactured friction and compute rationing. If you are a free tier user, the AI company is losing money on every prompt you enter. So they will throttle your experience. You will experience slower generation speeds. Your AI assistant will be given a smaller context window, meaning it will artificially forget earlier parts of your conversation to save memory processing costs.
The AI will become artificially dumber to save the company money.
Exactly. You will experience poor coordination between apps. When you ask your free AI to plan that trip to Chicago, it might only check 2 restaurant databases instead of 20, because every database it checks costs the AI company a microtransaction fee paid to the publisher.
Wow.
The platform will optimize the free experience to be just good enough to keep you in their ecosystem, but restrictive enough to push you toward expensive, paid, premium AI tiers.
Or they will force you to surrender more personal user data to subsidize the cost of their operations. The era of the completely open, frictionless, free web is closing. If data costs money and processing costs money, the underlying economics always trickle down to the end user. You pay with your time, your patience, your privacy, or your wallet. The agentic economy stabilizes the publisher's business model, but it inherently introduces a toll system into the very fabric of the internet's infrastructure.
It is the financialization of every single digital interaction executed at the speed of light by autonomous machines.
Well, let's take a breath and recap the incredible journey we've just been on. We started with the tipping point, that moment when automated HTML traffic surpassed humanity, hitting 57% of all web requests. We looked at the architectural shift from passive, lightweight search crawlers to active, computationally heavy AI agents that use headless browsers to simulate human interaction, overwhelming servers with their multiplier effect.
And we broke down how that complex baseline traffic provides perfect camouflage for modern Layer 7 bot bombings, attacks that exhaust a server's application logic and database memory rather than its network bandwidth. We explored how AI-generated code introduces the exact vulnerabilities these bots exploit, and how advanced computer vision and simulated biomechanics have rendered visual CAPTCHAs completely obsolete, forcing a shift toward cryptographic hardware attestation.
We analyzed the geopolitics of this traffic, contrasting the massive, strategic data extraction operations aimed at building AI moats with the targeted disruptive sabotage of cybercriminal syndicates, always keeping in mind that global proxy networks make IP attribution a dangerous game of smoke and mirrors.
We then dissected the macroeconomic crisis. We examined the biological limitations of the human attention economy and how retrieval-augmented generation broke the foundational social contract between search engines and publishers by synthesizing data without providing human referral traffic, leaving publishers to bear the compute costs without the economic upside.
Which brought us to the resolution, the birth of the agentic economy, the shift from monetizing human attention to monetizing machine access. Publishers are deploying pay-per-crawl licensing, dynamic multi-armed bandit pricing models, and machine-readable metadata to sell their intellectual property directly to verified AI agents via automated microtransactions. It transforms web infrastructure into a massive business-to-robot marketplace.
With the final consequence being that the consumer ultimately bears the friction of these new systemic costs through compute rationing, throttled AI performance, and the aggressive extraction of personal data.
It is a total rewiring of our digital world, from the physical hardware up to the economic theory. And I want to leave you with one final, slightly chilling but endlessly fascinating concept to mull over. We talked at the very beginning about how we are now the minority on the internet. We talked about how the most lucrative, most reliable, most financially capable paying audience for a publisher is no longer a human being, but an autonomous machine with a microtransaction budget. If that is fundamentally true, if the underlying mathematics of the internet dictate that your biggest, best customer is an algorithmic AI agent, how long until our writers, our journalists, our data analysts, and our creators stop making content meant for human eyes entirely? How long until everything we research, write, and publish is structured and optimized solely to please the specific ingestion protocols of the machines that are buying it? What happens to human culture, to art, to journalism, to the way we document our own reality, when our primary audience, the audience actually paying the bills, doesn't have a soul?